So you're going to do tests at, 100% load, 90% load, until you can't do any more loading. So when I'm talking about load, we're talking these guys, we got 20 switches. So full load would be 100, or all 20 switches on, 90%, 18 switches on, so forth and whatever. So first off, we'll get this up and running. And this is a DC generator, so it doesn't specifically require any set speed. So this gives you guys a little bit more freedom to do some cool testing on it. So I would say for your first time around, just pick a number above 1500 and below 1800. So anywhere in that range. And that's going to be your operational speed. Right? So if we pick 1600, boom, we're going to make sure we pull up to that 1600 RPM. And we're going to apply full load and maintain 1600 RPM. Then we're going to take some numbers. So we're going to want to make sure how much power we're taking out. So your armature voltages and amperage. So DC power, volts times amps equals watts. Nice and simple. Then we're going to take our gas flow. So there is a gas meter at the back, and it's going to require someone with a stopwatch or timer on the phone, whatever you got, and you're just going to see how many cubic feet per time period. And we're going to use that. That's the only data you need for your thermodynamic efficiency. So that's it. You only need your gas flow when you're at full load and normal operation speed.
Gas flow, full load, normal operations.
Yeah.
Okay.
So we'll cover that more, but that's not really the big thing. So once you have your baseline set, you're at 100% load, 1600 RPM, you got your volts, amps, speed, gas flow recorded, then we're going to do the actual Morse test. The key thing here to do a good Morse test is from here on out, you don't touch the throttle. You keep the same gas flow going in as you had at base load. So what you want to do is we got 3 cylinders, and on this control panel we have a switch per spark plug. So we're going to deactivate a spark plug. The gas is still going to go through that cylinder, but it's not going to be ignited. We will have no more power stroke from this one cylinder. So because we lose one cylinder, we're going to drop in speed. Now, without touching the throttle, what we'll do is we'll unload, take off load until the speed gets back as close as we can to that speed, 1600, whatever we choose. Then we retake our voltage and amperage. Then we want to put the cylinder back in service, bring it back up to normal, our full load, 1600 RPM. This is the time where you can readjust the throttle if anything kind of wiggled out of place, reset it. Then you do the second cylinder. Kill the second cylinder, unload it till it's back to speed, record your numbers, put it back to normal. And then the third cylinder. Then that'll be your 100% load, numbers all collected. Then you're going to move to 90% load. So now you'll have 18 switches on, and you'll adjust your throttle till you're back at that speed, 1600 RPM. Then you do the exact same thing again. Kill cylinder 1, unload till you're back to speed, record your numbers, put it back in service, make sure it's back to normal, kill cylinder 2, unload, record numbers, back in service, cylinder 3, and then you move to 80%, so 16 switches, 1600 RPM, over and over and over again. So with this engine, because it's DC power, we can do one set of Morse testing at 1600 RPM, 1700 RPM, so on and so forth. So you can do that. My one requirement is at least at one speed. If you do that one speed thoroughly, all those points, and you got all that data, then I give you guys the option. You can go do the same test on the diesel engine, or you can do different speeds on this engine. Either up to you guys, however you want to do it. So the diesel engine, exact same idea, except instead of killing spark plugs, we're just bypassing fuel around the cylinder. So same idea, it's not producing a power stroke, and we're going to record the amount of energy lost from that cylinder not being in service. All right, does that make sense? Yeah.
When you, okay, so you have load on that, you kill the cylinder, take the load off. For it to come back up to the exact same speed, like let's say we're doing 1700, do we have to play with the throttle?
No.
It will go back.
Yeah,
okay.
so you're going to get as
don't touch the
close
throttle
as
at
you
any
can.
point.
Yeah, like this tachometer is just a dial, so you're never going to get exact with this dial anyways, and you're never going to get exactly back to where you were with just these loads. So you'll get close and make a judgment call.
So don't touch the throttle.
Don't touch the throttle.
Okay.
Yeah.
Effort.
On startup.
Start
We'll start it there.
to make sure
Yeah.
you're at the same slope.
Got it.
In other words, you can't reverse speed, right? Easy.
This one, nah. Like usually, what I
It only
see
goes
people
so
do
fast.
is 2 people, one on the valve or one on the load, one on the throttle. And when we kill the cylinder, speed's going to go down, and nothing to worry about there. But when you put the cylinder back on, speed's going to come back up. So you can lead by putting a couple switches on, then putting the cylinder back in service, and that gives you a little bit more, couple of seconds to catch up to it. All good?
Okay.